All right, so this week you're going to be working on your conceptual activity assignment. If you looked in the weekly overview, you will notice I gave an explanation there. In your syllabus, this was supposed to be in week 6, which is next week, but I think this is really a better fit to go ahead and do this week and wait to do the lesson plan analysis next week for two reasons. Number one, it gives me time to actually sit down and randomly assign these. That's a process that actually needs to be pretty thoughtful, so that no one is left out, and no one ends up getting their own. And some people, of course, may have submitted those late, and I don't want anybody to end up without one. So if I have this week to sort of do that and get that set up, it makes more sense for you to next week be able to do the analysis. In addition to that, next week I will be posting a study guide of sorts. Some of them will be problems you've already seen, either through the discussion board or through maybe a homework set. But in general, a document that will give you some idea of what the final exam might look like. And I imagine that the majority of you will want to spend a significant amount of time working through that, getting the solutions to that, getting some feedback, et cetera, et cetera, et cetera. Since that's probably going to be a large task and the lesson plan analysis is a much smaller task, that would be a better fit to allow you some time to work on that study guide. Okay, so that's my thinking. So what is the purpose of doing this? Number one, I want you to be able to be confident that you can pick out activities that are conceptual in nature. That's not necessarily as hard as you may think. Okay. Conceptual activities don't have to be huge, great, monstrous activities that students do. They can be actually quite simple. However, the goal of a conceptual activity is it is going to use some sort of a model to make what is for students a very abstract concept concrete. It's going to focus on the action of what is going on when we add, we subtract, we multiply, divide. It is not going to focus on step one, I do this, step two, I do that. That should not be anywhere in your activity. The only example I can think of that wouldn't necessarily match that is if you are using a sharing activity to build the process of the standard algorithm for division. If you watch the video I had up, I think it was in week 3, where you could submit some problems for some bonus points. And you looked at the video about how to explain standard algorithm for division conceptually, then you will know what I mean. Okay, that sharing process will help you understand that algorithm. So that is one exception where you might be talking about a process. The rest of these are going to be making sense of what is happening in mathematics when we are adding, subtracting, or multiplying. You also may have activities where you use base 10 blocks to talk about borrowing and carrying. Again, it's okay to relate to the processes, but the processes are not the focus of your lesson. Okay. Now, what does it mean to be an activity? Students will be usually either paired. It's possible that they could be working alone, but they will have some manipulatives. They'll be making sense of a situation. Please do not put a worksheet of problems in here. That does not count as an activity. To be active is usually the definition there. If we can be active physically, we also can be active with conversation, we can be active with manipulatives, but simply having a sheet of problems to solve does not count as an activity unless they're being asked to do something with those problems. Okay, so what are the instructions for this? You've already seen this, hopefully, basically posted in the description of the activity. But you're going to choose one conceptual activity for each of the 4 basic operations. So you're going to have one activity for addition, one for subtraction, one for multiplication, and one for division. This does not have to focus on the algorithm. It can just focus on what does it mean to add? What does it mean to subtract? This is all depending upon what grade level you're trying to target, okay? Your textbook has some really good activities in it. I would encourage you to look in the chapters that address those specific operations. And 9 times out of 10, you can find a really good conceptual activity that's there, and most likely a good explanation of how it's supposed to work and what you're looking for. If you ever were to keep a textbook in your life, I would strongly suggest that you keep this textbook. That's just how good it is. If you ever think that you may ever be teaching math, whether in a resource room or in an elementary room, there's just a lot of great activities in there. So that's a good place to start. Whenever you choose your activity, I want you to tell me what Kentucky academic standards and standards for math practice that you're going to be demonstrating. Okay. What standard are you trying to teach by this activity? In the classroom, we can't just do activities because we think they're cool. We have to know that they align with the standard. That's part of our job, and that's a legal requirement of teachers in Kentucky. We have to teach the standards. So making sure your activity matches, that's really important. For each activity, you want to have a sentence or two that lets me know what are you wanting to see in your students' responses or their behaviors to let you know they've mastered this. And how are you going to document that? If you remember from last week, that's really all about formative assessment. Okay. It can be whole group. Okay. It could be something like a running record. It could be individual, could be something like an exit slip. All of those are possibilities. Okay. So this is a general rubric and formative assessment. Again, this doesn't have to be hugely detailed. What are you looking for? Okay. And how are you going to record that? That's a big idea here. Remember that each activity need not be dedicated to performing an algorithm. It can be dedicated towards getting a student to conceptually understand what it means to divide or add or multiply or whatever the case. For one of these activities, you're going to need to incorporate technology. Okay. Now that's up to you. The only stipulation I put on here is that it cannot be used as presenting material for the teacher. Like you can't show a PowerPoint and call that technology. Okay. It should be student use of technology, and it should be meaningful. Okay. You could have them use Chromebooks to access digital manipulatives. Okay. There are online base 10 blocks. You could use Plickers, or you could use a myriad of other types of technology. You could use Google Forms to have them submit an exit slip. That is all up to you. That's up to the grade level in which you choose. But in one of those, you're going to choose some sort of technology. Okay. It is perfectly okay to find an activity that you want to use. Okay, so this doesn't have to be one that you have created on your own. It can be one that you found somewhere else, but please make sure you document that if you have. Otherwise, if I were to find that activity in someone else's submission, and neither one of you had it documented, then we would probably have an issue there to address, okay? Because it then looks like you have either copied from someone or something along those lines. So again, it's perfectly reasonable that you might have a single activity or so that's like someone else if it came from a website that both of you had visited. But please, please, please make sure that you document that. Okay. So you also have to submit complete instructions to perform the activity. You should include any handouts that you're going to say that the students need. So if you're going to say that you're giving them, a list of scenarios to follow, then you should include a list of those scenarios with you. The purpose of all of this is that once I have reviewed the activities, graded those, assured that they do what you say they do, then I'm going to combine them into a master document. You will have one for addition, subtraction, multiplication, division. And then I'm going to send that out through email to the entire class. So the hope is that when you go into the classroom or as you're working through resource, wherever it is that you end up, you have a nice little stash of conceptual activities that you can pull out and do that don't require endless amounts of planning on your part. Okay. So how is this going to be graded? Here are the things I'm looking for. It's a 45-point assignment. Okay. I need 4 activities that match the operation you indicate. Please make sure that these are not multiple operation activities. You want to do something that's wholly focused on addition, that's wholly focused on subtraction. If you chose to address an activity that incorporated more than one, it would still only count for one of your 4. One of those operations you would have to include another activity for. Okay. The activities are conceptual in nature. Again, what does it mean to actually do this? Even if you're focusing on an algorithm, why do we do what we do in the algorithm? You're making it concrete, and you're getting them to understand the concept of these 4 operations. Your activities clearly state what you're looking for from the students to indicate they have mastered whatever it is that you say you want them to do. And you've included proper standards and standards for math practices for each activity. You've included technology in at least one lesson that benefited student learning. Again, this is not just for teacher presentation. Again, submitting an exit slip. I realize that that doesn't seem a lot like it's student learning, but if you're going to use those responses and analyze those responses and use that to reteach, then it is definitely benefiting student learning. Okay, so what would an example of this be? Now, I just came up with this probably within the last 20 minutes or so, so it's pretty quick, but this is kind of what I'm looking for. Operation that needs to be up there first. What operation are you telling me that this is concentrating on? I'm going to concentrate on division. My goal here, I'm not writing this like a formal learning target. Okay. I'm just telling the reader in general, what am I trying to do with this activity? So here I want students to visualize the concept of what it means to divide through sharing and partitioning. If you read the chapter, you know that there is another model for division, which is division by subtraction, repeated subtraction. Okay. They will then show their actions with a math sentence. Since we're in elementary school, I shy away from calling this an equation, but that's exactly what it is. So here's my Kentucky Academic Standard. Use multiplication and division. Of course, I'm going to be focusing on the division within 100 to solve word problems in situation involving equal groups, arrays, and measurement quantities by using drawings and equations with the symbol for the unknown number to represent the problem. Okay, so my symbol I used was just a blank. You could use a box. You could use an X. I probably wouldn't use an X in elementary school, but some sort of symbol to represent what we don't know. Okay, so my S&Ps, I'm going to expect that the students will make sense of problems and persevere in solving them, and model with mathematics because I'm giving them a set of base 10 blocks. They're going to act out these scenarios using these base 10 blocks. So they're modeling. I'm going to give them a handout of the scenarios I want them to model. And of course, they're going to have pencil paper. What am I looking for students to be able to do? There's really a few things here I'm looking for. I want them to be able to accurately represent quantities with base 10 blocks. If they can't do that, the rest of it's not going to matter. Okay. No matter what number I give them to divide, if they can't accurately show me that number in a base 10 blocks, it doesn't matter if they share it right or not, they're not going to get the right answer. So that's the first thing I'm looking for, accurate representation of the quantity. Then I'm going to look for, can they share these correctly from the largest to the smallest block? Now, again, why do I want to drill that into them really early to start with the largest and go to the smallest? Because they don't know this, but later on, that is how standard algorithm works for division. That's why we start with the largest number and then we scoot over because essentially we're trading down. And two, it will help them to only have to trade once instead of multiple times. So I want to start with the largest block. If I can't share it, trade to a smaller block, then share. If I can't share that, I'm going to trade down as needed. I also expect them to translate the action they modeled in this scenario with the blocks into a math sentence correctly. Okay, so there's 3 things I want to see. Represent the quantity, share it by trading down, and then represent what I did with an equation. There's really 3 things I'm looking for. I'm going to make notes on a running record as I circulate the room to assist and encourage students as needed. Okay. Through my notes, I hope to identify both struggling students who need reteaching and the major misconceptions that the class may have. So again, just general few sentences. I didn't have to write out what I'm going to use. I did put down that I'm going to do a running record. If you were going to have them turn in as an exit slip, or depends on how you want to approach it, as a whole group or as an individual formative assessment. The activity I'm describing is probably best used in an introduction type of lesson. So that's why I'm evaluating it more in a whole class type scenario. Whereas if this were a lesson that was well past the introduction, where you're expecting to see students start to master this concept and grow some extensions from this, then I would probably be doing an individual formative assessment, maybe an exit slip or something like that. So here's my sample scenario. And again, because this is just an example, I only put a single scenario here. However, if this was something I was going to turn in, I would want you to have an adequate number of samples. Now, since this is division, what would an adequate number be? Well, I would want them to be able to think about all parts of this equation or number sentence. Okay, I might give them a set of models already drawn. I might have them draw the model, which is what this first scenario does. Okay, Jessica has a collection of 48 Barbie dolls. Her friends visit. Everyone wants to play with her dolls. Write out the words in words, your strategy for answering this problem. Okay. You don't have to have this answered, but I just kind of drew in what I would expect students to have here. What is my strategy? I'm going to take my 48 Barbie dolls and share them among 6 people. Okay. So here's 48. I've represented with 4 longs and 8 ones. And then I say that I must trade each long for a single. And then I can share 48 singles one at a time. Why is that so important? I would expect the student to do it one at a time, because we're not here to know if they know their multiplication facts. I have so many people tell me, well, they can't divide because they don't know their multiplication facts. I realize that that is a hindrance for students, especially when you're trying to teach them how to do the standard algorithm. However, it should not be a roadblock that prevents them from being able to access the understanding of what it means to divide. Okay, if they really can't divide because they can't multiply, then it's not being taught conceptually. So, one at a time. Why is that important? We don't expect them to know that 48 divided by 6 is already 8. Okay, if they hand these singles out, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 3, and so forth until they use them all, they will know how many is in each group and if we have any left over. Again, that might be another way I work up through scenarios. Okay, this is an equal group. I don't have any left over. However, if I did, that might be a way to increase the difficulty of the problem. Okay, and you might even ask, what might you do with those 3 leftover Barbies? Okay, that's a problem solving strategy for students to think about. So again, this is one scenario. You might include more than one. You would not have to answer them. Okay, that would be something that whoever is maybe using the activity in the future might do. So this is an activity for using base 10 blocks to represent the process of division and understanding what it means and getting the students to put that in a division sentence. Now here I left a blank. If you wanted to use a symbol, you could use a block, maybe a star, some sort of a shape, get them to fill that in. Again, my purpose for this lesson is to be an introduction to what it means to divide. Okay. Your activity can be much more involved than this. It could be just as simple as this. But I have students talking to each other, have them in pairs performing this. I have students using manipulatives to model a real life situation. That is a conceptual activity. That's what we're looking for here for each one of our operations. If I wanted to turn this into a technology activity, I might have my students use those digital manipulatives. I would have to include a website for that. I also might have them use a Google form to respond to maybe a question I'm going to share with the whole class at the end, and I want them to try this question individually. Might do that on a Google form. If some way to incorporate technology needs to be for student learning, not for teacher presentation. Okay, so if you have questions on this, you can give me a call. Remember, or I'm sorry, not a call, but an email and we can talk through it. It doesn't have to be a great, huge, involved activity, but you do want to have those parts that we discussed there. So each person who may get this in the future is going to have, an idea of what they need to use it for. If everyone submits theirs, you should have around 30 to 32 activities in addition to your own for each one of the operations. So it's a good start to keep you from having to create and plan a lot of these on your own, and hopefully that helps out some in the classroom.